Welcome to Lesson 07. This is where the brain becomes muscle. Stage 02 left us with decisions parked in the LAPI database. Now we wire those decisions into actual kernel-level enforcement using the oldest, fastest path there is, a firewall bouncer polling LAPI, pushing IPs into IPTables or nftables, and letting the kernel drop the packet. By the end, you'll have crowdsec-firewall-bouncer running, an IPSET full of banned IPs, and the muscle memory to debug it when something slips through. So let's map the full pipeline. Agent detects and overflows a scenario, writes the decision to LAPI. That's stage 0102, the brain. LAPI stores it and serves it over the streaming endpoint we covered in Lesson 06, diff format, new and deleted lists. The bouncer polls that endpoint every 10 seconds and translates each decision into an IPSET entry or an IPTables rule. Then the kernel does what kernels do. 01, lookup, packet dropped, no user space traversal, millions of packets per second if you need it, brain, bridge, muscle. Now, the muscle comes in 3 flavors. Same go binary, 3 different outputs. On modern Linux, you want nftables, native set operations, default on Ubuntu 22 and up, Debian 11, RHEL 9. Older boxes, Ubuntu 20.04, RHEL 8, every Docker host, that's IPTables territory, backed by IPSET for 01, lookup. BSD shops, pfSense, OPNSense, PF, via the plugin. Not sure which you're running? Run sudo nft list rule set. Empty or error means IPTables. Output means nftables. Pick once, install the matching package, move on. Once you've picked your backend, install is genuinely 3 commands. apt install the matching package, IPTables or nftables flavor. And because the bouncer lives on the same host as LAPI, it auto-registers. No token shuffling. Verify with csecly bouncers list. You want a valid yes and a firewall bouncer type. Then systemctl status, and you should see that first sync line. 8,000 decisions pulled from LAPI. That's the brain handing the muscle its marching orders. Now let's crack open the config that wires it all together. This YAML file lives under crowdsec-firewall-bouncers, and honestly, most fields are sane out of the box. Update frequency at 10 seconds, deny action set to drop. The 2 you actually touch, APURL and API key for auth, and mode to match your backend. And if your bouncer is remote, different host from LAPI, you point APURL at the LAPI box and generate the key with CCLI bouncers add over there. Bookmark this slide. You'll come back to it. So why does the bouncer reach for IPSET instead of just shoveling rules into IPTables? Performance, plain and simple. Raw IPTables means 1 rule per banned IP, and the kernel walks that chain linearly for every single packet. At 10,000 entries, your CPU is on fire. IPSET flips it. 1 hash table in kernel space, 1 IPTables rule that asks, is the source in this set? 01, lookup no matter how big it grows. Want proof it's running? Sudo IPSET list crowdsec blacklists, piped ahead, and watch thousands of IPs scroll by. Knowing it's running isn't the same as knowing it works. So here's the 4-command audit. Trust, but verify. Inject a manual decision against a safe test net address. Wait 10 seconds for the bouncer to poll LAPI, then confirm the IP landed in the set with a timeout counting down. Check that IPTables actually references crowdsec blacklists, then watch the PKT's column climb as spoofed traffic hits the drop rule. That climbing counter is your proof. Brain became muscle. Clean up with CSCLI decisions delete and you're done. Now, if you're on a modern distro, you're probably already on nftables whether you realize it or not. IPTables L is just a translation layer these days. Flip the bouncer's config from IPTables to nftables, restart, and crowdsec spins up native sets without needing IPSET at all. The big win? It lives in its own innet crowdsec table, completely isolated from your existing rule set. Easier to audit, trivial to rip out. Same brain, same muscle, Cleaner anatomy. Cleaner anatomy is great, but eventually you'll hit a setup where the defaults don't cut it. 4 knobs matter. Update by frequency is your poll interval. Drop it to 1 second when you need near-instant bans. Push it to 30 when Lappy is across a slow link. Log level stays on info in prod, flip to debug when bans go missing. Disable the IPv6 if you're v4 only. And set size, bump it past 131K the moment you're pulling a community block list with hundreds of thousands of IPs. Realistic end-to-end target, under 30 seconds from overflow to kernel drop. 10-second poll plus 5-second Lappy tick lands you around 15. That's the number to beat. Tuning's done. Now the failure modes. 5 gotchas every firewall bouncer operator eats at least once. Number 1, IPSET empty, decisions present. That's auth. Check the valid column in CSKLI bouncers list and recreate. 2, IP in the set but still getting through. Your chain config misses forward or Docker. Add Docker user. 3, IPv6 leaks past an IPv4 only IPSET. 4, duplicate match set rules stacking every poll. Stale cache under varlib crowdsec nuke it. 5, you SSH banned yourself. Console in, delete the decision, then whitelist your home subnet so it never happens twice. So let's recap what you actually own now. 6 skills. The bouncer architecture polling Lappy every 10 seconds and pushing diffs into kernel state. 3 backends, IPTables, nftables, PF, same Go binary. A 3-command install that auto-registers, a config you understand and won't overtune. IPSET giving you O1 lookups instead of linear IP tables misery, and a verification loop using IPSET list and the packet counters. Decisions became dropped packets. Brain became muscle. Lesson 08 takes us up the stack. Nginx, Trafic, CAPTCHAs at L7. Lesson 7, complete. Kernel drop is real. You've got bouncer architecture, IPSET internals, 3 backends mapped, and enforcement verified against live packet counters, but the kernel only sees IPs and ports. Lesson 8 takes us to Layer 7, Nginx and Trafic, custom 403 pages, CAPTCHAs, redirects. When an IP isn't enough and you need to challenge a human. Run next lesson, start when you're ready. See you in 08.